Welcome to Design and Analysis of Algorithms class. In today we are going to start our fifth unit, which is branch and bound. Right? So under fifth unit we have two modules. The first module is backtracking and the second module is branch and bound. Both are algorithm techniques or both are programming paradigms. Right? So today we are going to see the next programming paradigm, which is branch and bound. So how to apply branch and bound and what are the different search strategies under branch and bound. Now although we have backtracking, why we are moving to branch and bound, all these things we are going to learn as part of today's lecture. Now, in today's lecture, I'm going to cover what is meant by branch and bound and what are the different search strategies we have. Those I'm going to cover. Now, coming to the objective. The main objective is the students are able to understand the concept of branch and bound and the outcome. After learning this lecture, the students are able to acquire the knowledge on branch and bound and they can apply branch and bound technique on a given application. Branch and bound refers to all the state space search trees or methods in which all the children of E nodes are generated before any other live node becomes the E node. Before any live node becomes E node. So here I'm having one word called state space search methods and E node and live node. Right? So here I'm having two unknown terms. What are they? State space search methods. So here if you want to search for the answer node or the solution node on a state space search tree, then we are using this branch and bound technique. Right? So whereas in your backtracking, what happens? For example, let us consider n-queen problem. Okay, under n-queen problem, okay, so here I'm having let us consider this n is equal to 4. So 4 queen problem. So here I'll be having a empty 4x4 chessboard initially, and here I have to place 4 queens into the chessboard such that no 2 queens should attack each other. Right? That is a problem statement regarding your 4 queens. So if I want to draw the state space tree for this, then what happens? So here if I want to draw the state space tree for this, I'll be having more number of nodes for this state space tree. For suppose if I want to draw for the first level, so for the first level in the given tree I'll be having 4 nodes. What are the 4 nodes here? Here I'll be placing q1 over here in that place, or else I can place here, or else I can place in the third column, or else I'll place in the fourth column. Right? So here I'm having, these are the 4 possibilities. That is, q1 can be placed in the first column or in the second column or in the third column or in the fourth column of your first row. Right? So these are the 4 possibilities. Likewise, again here if I'm expanding it here also I'll be having some more options. Right? So likewise, if I want to draw the entire state space tree, it will includes around 60 nodes. Right? So here for drawing the entire state space tree, it is very difficult, right, to find the solution. Whereas if I'm applying this branch and bound, it is very easy for us to get the solution node, right, or the answer node. Solution node, or okay, to get the solution node or answer node. So how to find this solution node or answer node is our next thing, right? So that for that we are utilizing this branch and bound concept. So now what is meant by live node and E node, right? There are 3 types of node basically: live node, E node and dead node. Those we are going to see now. Now, branch and bound is a generalization of 2 graph strategies. They are BFS state space search and a D search like state space search. So BFS is also called as FIFO, first in first out, and D search can also be called as LIFO, last in first out. Here the list of live nodes, in the first in first out fashion for the BFS like state space tree. That is, for BFS, here this is following the principle called FIFO. So all the live nodes in the FIFO order. Now, whereas D search is following LIFO. Okay, so all the live nodes, all the list of live nodes in the last in first out fashion. As I said earlier, there are three types of nodes. The first one is a live node. So live node means a node is being generated, that has been generated, but whose children have not yet generated. A live node means that is generated, but whose children have not yet generated. E node means expanding node. E node, which is currently, whose children is currently being generated. Here a live node whose children are currently being explored. In other words, E node is a node which is currently being explored. So here, which is currently being explored or expanded, right? Now, dead node means here for that state space tree all the nodes have been generated and there is no E nodes to expand further. So dead node is a generated node that is not to be expanded or explored any further. So here corresponding to the live node means it is the node is generated and whose children have not yet been generated. Whereas coming to E node means here which is a live node, where for the live node the children are being currently generated. Whereas coming to dead node means whose children have already generated and there is no children to explore further. Okay, now there are basically three types of search strategies, and the first one is FIFO, and the next one is last in first out, and the next one is LC search. There are basically three types of search strategies we are using under branch and bound method. So here the first one is first in first out, second one last in first out, third one is LC search. Right, now let's see the first one, which is FIFO, branch and bound. FIFO. So FIFO principle is generally used by a data structure called Q data structure. So in this particularly we are utilizing a Q data structure. So now let's have an example where here this is my solution state space tree, and here this one, whatever is a rectangular node, that is my answer node or solution node. This is my solution and this is Q, and which is initially empty, right? And here these are the nodes. First node corresponding to which is having 3 children. This is a root node and it is having 3 children, and now 2 is a parent, it is having 2 children, and again this is a parent and it is having 2 children. So likewise I'm having a small example state space tree. Now let us see, right? Initially the Q is empty, and assume that node 12, here node 12 which I have shown you, right? So this is your answer node or solution node, and in FIFO search initially E node as node 1. So initially I am taking the E node as a node 1 because node 1 is a root node. So now we will place all these live nodes in the queue. So node 1 is having the children 2, 3 and 4. So first of all I need to keep 2, 3, 4 in the queue, right? Now what is our principle? Our principle is first in first out. So what is the first element? 2. So that 2 node will be deleted from the queue. So in our next step this 2 will be deleted, and here I will be having 3, 4 and remaining, right? So now this 2 will be deleted, and now whatever is I am deleting, that will be our E node for the next level. So now this 2 is now E node. Now whose children are 5 and 6, right? So now I need to insert this 5 and 6 into my queue. I have to delete this 2, and now I have to make this 2 as a E node. And now what are all the children for this E node? Those values I need to insert into the queue. So now what is the next status of queue? Empty one, 3, 4, 5, 6. Now again, what is the next value to be deleted? 3. So now this 3 gets deleted, and now this 3 is having the children called 7 and 8. Now this 7 and 8 will be discarded. This 7 and 8 will be discarded by the bounding function. Why? Because here that 7 and 8 itself, they are dead nodes. So which means that there I don't have my solution node. So simply by using bounding function, that will be removed. Now what is the next one? Again this 4 gets removed. Okay, again this 4 gets removed. Now at 4, what is the children? Now 4 becomes the E node. Now for 4, what is the children? 9 is a children node. Now again that 9 is a dead node, right? Because from 9 there is no exploration. So again 9 is a dead node. So by bounding function, even that will also be removed. So now what is the next element? 5. Again 5 gets deleted. 5 gets deleted, and 5 children, now 5 becomes E node, and 5 children are 10 and 11, right? Again even these two are also not exploring for further. So even these two are also will be deleted by using bounding function. So now what is the last one? I'm having 6. So now this 6 gets deleted. Now 6 will becomes E node. Now this 6 consisting of a children called 12, and that is my solution node. So simply I found it, and I'll stop my search. So this is how I will apply FIFO branch and bound searching. So here initially the root node will be taken as a E node, and now that root node is having 3 children, and those 3 children will be keeping into the queue initially 2, 3, 4. As the queue is following the principle FIFO, initially the first element which is get into the queue will be deleted, and the deleted element will be the E node for the next level, and that E node is having the values. The 2 is the E node now, and whose children are 5 and 6, right? So that 5 and 6 will be inserted into the queue. Now after in the next iteration, the 3 will be deleted, because the 3 will be in the next value. That 3 will be deleted, and again the 3 will becomes E node, and the 3 is having 2 children called 7 and 8. Now as that 7 and 8 are not exploring further, so by using bounding function, that 7 and 8 will not be considered and will not be inserted into the queue. So now again that 4 will be deleted. Now 4 becomes E node now, and 4 is having the child called 9, and even that 9 is also will be deleted by using bounding function. Now finally that 5 will be deleted, right? So here I am having 5. So now 5 will be deleted, and 5 becomes E node. As a 5 is having the 2 children 10 and 11, even those are also not producing the solution, so those will be deleted by using bounding function. Now last element will be 6. Now 6 gets deleted, and now 6 becomes a E node. Now the 6 is having the children node called 12. So now as a 12 becomes 12 is our solution. So finally that search will be terminated, and finally we found our solution. This is how we need to apply FIFO branch and bound search strategy. So now let's see the second strategy, which is LIFO branch and bound strategy. So there also the same thing, but instead of queue we will use stack concept. Instead of FIFO principle, here we will use a concept called last in first out. So the same thing I am showcasing here. So here node 2 will be our E node, and node 2 is having the children 3 and 4, and now as a node 2 is having 5 and 6, I am going to insert over here. Next delete the element from queue and take it as a E node. The same thing I am explaining you over here with the help of figures. right? So finally the child of node 6 is at 12. As it satisfies the conditions of solution node, the search will be terminated. Now let's see LIFO branch and bound search. So here also I am taking a same example where this 12 is a solution node, and here I am initially considering the stack as a empty. Right? Now initially my stack is empty. Now generate the children of node 1. So because node 1 is a root node, so root node is having 3 children, 2, 3, 4. So I need to insert them into the stack. Nothing but push all these into the stack. So here while inserting, so here the first one, here I am having 2, right? So whatever may be the last input, that will be the first output, right? So here remove the element from the stack which is the top. Now generate the children of it and place those nodes into the stack like your queue operation. So here 2 will be removed, and whose children are 5 and 6. So 5 and 6 are being inserted or pushed into the stack. Now again in the next step 5 gets popped, and the 5 children are 10 and 11. Those will be inserted into the stack. So likewise the search process remains continuous until node 6. Okay, whenever I am popping node 6 whose children is 12. So in that case I found the solution. So in that case simply, as I found the solution, simply it will terminates and it will returns the answer node. Okay, this is how your LIFO branch and bound search strategy works. And the third strategy is LC search or least cost search, that we are going to cover in the next session. Now coming to the summary. So today we have covered what is meant by branch and bound and what are the different types of nodes we have: live node, dead node and E node. And also we have covered the search strategies. There are basically 3 search strategies. The first strategy is LIFO branch and bound, next one FIFO branch and bound, and next is LC search. And this is a small assignment: generate 4 queen state space tree using FIFO branch and bound. Okay, thank you.